So the last lesson, we're going to do 3.6, and these are going to be all applications, all our applications, okay? We've had application problems before. We've had half-life and population increasing. Now we're going to do money. We're going to do some money problems, okay? Yeah. The book calls it Mathematics of Finance. I call it money. All right, so do you want to make money when you get older? Yeah. Do you want to have a nice retirement plan for when you retire and you have money? Yes, of course. All right, yes, this is econ, totally. Here we go. We're going to start with some simple and compound interest. Now, all of these formulas I will give to you. Every single formula we write down today. But you need to know which one for which problem and what the variables stand for and stuff, okay? So here we go. Compound and simple interest. I'm going to go ahead and give you, I'm going to teach this a little bit differently than I did in my first period. I'm going to give you all the 4 formulas right now that go with this stuff. You have more formulas at the end. So here we go. First of all, if you had a simple interest is, let's say you invest $100 and they're going to give you 5% at the end of each year. And then you take your 5%, great. And then the next year, it's still on the $100 you invest 5%. And then the next year, it's still just on the principal amount, okay? That's simple interest. It's linear. It looks like this. A equals P 1 plus N times R. There's no exponents, nothing like that. That's simple interest, okay? It's not very good. Then you have compound annually. Compound annually. So this is, let's say you invest that $100 at 5%, then they take that money that you got that first year and they compound it. They put it back onto your amount, and now the next year you're making more money because you have more money in your account. So that looks like this. A equals P times 1 plus R to the N. And that looks familiar to you, right? We have. Okay, now this one you have not done. The next one I'm going to give you. This is when you do compound K times a year. K times per year. So the last one was once a year. It's annually. K times per year means maybe they take the interest and they compound it monthly or daily or quarterly, and that would look like this. A equals P 1 plus R over K to the, they say KT, but it's like KN, it's the same thing. Let's just do K times, let's do KT. Yeah, and I'll tell you, we're going to write down what all these variables are. Okay, so that would be a little bit more complicated, as you see. There's a fraction in there, there's 2 numbers up there. And then finally, the last one is compounded continuously. Compounded continuously. Sometimes we abbreviate that as CC. Does anyone remember what that one was? PERT.
Oh, PERT.
Yeah, A equals P e to the RT. Okay, so we went from simple to infinite, just like that. And you have to know which one to use. Okay, so let's go ahead and talk about what each variable is. That P that you see there is your principal. It's the amount that you're going to invest, and then you're just going to leave it alone. Okay? So I put $1,000 into the bank for 3 years. Okay? That doesn't change. $1,000, I'm not adding to it. I'm just putting $1,000 in and walking away. R is going to be the rate that they're going to give you, the percentage rate. If you can find a good rate, that's good. N is the number of years, and so is T. I don't know why they just wouldn't use that. Number of years, and T is also the number of years. Okay, and then K is the number of times per year. Number of times per year. So how many times is that Nordstrom sale? It's twice a year. It's a semi-annual sale. Yeah, you know that. So semi-annually would be 2. Okay, it's compounded twice a year instead of just once during the year. All right, so let's do one of each of these, okay? So here we go. And let's see what the difference is each time. We'll use the same amount for each person. So number 1. we've got Bob, Carol, Rick, and Jim. Sure. Bob, Carol, Rick, and Jim. Bunch of old people, huh?
Yeah.
These are like old names. How many formulas are you? Okay. Now, all four of these, they're going to invest $5,000 at 2% interest. And they're going to do this for 4 years, but they're all going to do it differently. So here we go. So letter A. Bob's going to do simple interest. So let's find out how much Bob's going to make in 4 years, or how much money he's going to have. He's still going to have that $5,000. He's just going to have more than that. Okay? That's why it's really important, especially athletes, right? When they make so much money and they just spend it, they should invest it, because what are they going to do once they retire, you know?
Play ball,
Become a coach sometimes, but sometimes you can't coach. All right, so here we go. The amount that Bob's going to have equals $5,000. We're going to do simple interest. So that would be 1 plus 4 times 0.02. Okay? So here we go. 5,000 times, you could do parentheses, 1 plus 4 times 0.02. And in his account, he's going to have, whoa, is that right? $5,400? Yeah. Yeah, that makes sense. Two boo-boos. Yeah, because what's happened here is he's making 2% on 5,000. So each year he makes $100. So at the end, hi Jonah, at the end he makes $5,400. All right, letter B. Now Carol, she's going to compound annually. Annual compound. Okay? So that's our nice formula that we're all used to. So we're going to go A equals 5,000, 1.02 to the 4th power. So 1 plus R to the 4th. So let's find out how much Carol's going to make. 0.02 to the 4th power. And Carol makes $5,412.16. Always round to 2 decimal places when you're doing money, okay? There you go. She made a little bit more. She made an extra $12.16. Good for her.
Announcement.
Okay.
Brandon
Oh, that's Andrew's. All right, Rick. Rick now is going to compound, let's do monthly. So his bank takes the money he's earned after the month and tacks that back on, and then the next month it tacks that on, that on. And you think, whoa, that's going to be a lot of money. It's actually not that much more. So let's go ahead and plug all these in. So it's going to be 5,000. And get your calculator out. If you're not doing this on your calculator, you really should be, because people in my last class were like, I didn't get that, because they're plugging in numbers wrong. So it's 0.02 over 12 to the 12 times 4. And if you have an older calculator, when you do that caret, you have to put parentheses around 12 times 4. Good job. If you have a newer calculator, you don't have to. So 5,000, 1 plus 0.02 divided by 12. Or you could do 12 times 4 in your head, 48. Okay, so there's 48 compounds now, because that's, you know, every month for 4 years. And so Rick, he's going to make a little bit more, $5,416.07. Okay, now the interesting thing is each time the person makes more, but the difference between the last person gets less and less. Like from here, from Bob to Carol, it was $12.16. From Carol to Rick, it's a little less than $4 difference, right? And now let's finally, what was it, Jim? Does anyone have an Uncle Jim? Grandpa Jim. No. All right, Jim is going to compound continuously. That's what CC means, okay? So compounded continuously would be A equals 5,000 E to the 0.02 times 4. Okay, so he's going to make a little bit more, but it's going to be less of a difference from the last one. Keeps getting less and less. Oh, a lot less. So he's going to make $5,416.44. Pretty good. There you go. Now the thing that makes this lesson difficult, because you're like, okay, it's just punching in formulas and stuff. You need to know which formula to use. Okay. This is all just, you start with an amount, 5,000, and you invest it at whatever they tell you to. Continuously is PERT. Yearly would be compounded annually, stuff like that. You need to know which one to use. Okay, those are all the easier ones of this type. What about when they ask me something like this? Number 2. Suppose that, yeah?
So when, for the compound, like K times per year, it'll be like when
Yes.
monthly.
Monthly, daily, quarterly, anything that has increments inside of a year.
Okay.
Yeah. But those are the ones you'll see. Semi-annually, that would be 2, would be K.
How do you know like number used, like for like 12, that would be like 12.
Yeah.
So
Mm-hmm.
How do you know?
Because you figure out what it is per year. So how many months are in a year? 12. If it said quarterly, that would be 4 times a year. Yeah. If I said daily, that number would be 365. Mm-hmm. Okay. Number 2. Judy, another old person, right? Judy. Judy has $500 to invest. Good for her. At 3.2% annual interest. And here comes the harder question. How long will it take for her to double her money? 2 what?
That's the answer.
No. How long to double her money? Oh, and she's compounding this monthly. No, quarterly. Let's do quarterly. Her to double her money, compounded quarterly. Compounded quarterly would be 3 times a year. I didn't spell quarterly wrong, or right. I spelled quarterly. Quarterly.
I thought it was
4.
Yeah, it's 4.
Did I say 4?
You said 3.
Oh, I'm sorry. Every 3 months. 4 times a year. Whoopsies. Okay. So Judy, $500 invested, 3.2% annual interest. How long to double her money? Compounded quarterly. All right. So you have to figure out which one to use. Okay, I see this compounded quarterly, so I'm going to use the one that has K in it. So her initial investment, her principal is 500. 1 plus R over K, so R is 0.032 over 4 to the 4 times T. I'm trying to figure out how long it will be. And this is going to equal what? 1,000. Now, the funny thing about this problem is it doesn't really matter how much you're investing. If I invested $1 million and I wanted to make $2 million, it's going to be the same amount of time. It doesn't feel right, right? It is. That's why rich people just keep getting rich. You have $500 and you want 1,000, it's going to take the same rich person the same amount of time to take $1 million to make it into $2 million. You're doubling your money. Yeah. I'll show you. Watch. If you divide first by 500, guess what that is over there? 2. Okay? It doesn't matter. If I put 1 million and that's 2 million, I put 1 billion and 2 billion, it equals 2. All right. We're going to solve this algebraically because you're so good at it. You did it over the weekend. You could, set that equal to y1 and that equal to y2 and solve, but that's boring. Let's go ahead and solve this algebraically. So let's take the log of both sides. We got the log of 1 plus 0.032 over 4. That's to the 4t. We're going to bring the 4t to the front and multiply. And it equals, don't forget, whatever you do to one side, you do to the other. So we need log of 2 over here. Everyone okay with that? Okay, the rest can be done on your calculator. I think you should do it on your calculator. We're going to divide by the log of all this stuff on both sides. And then I'm going to divide by 4 at the very end. So let's see if you can do this. You should put log 2 parentheses divided by log of 1 plus 0.032 divided by 4, close the parentheses. I would hit enter there, and then I would, at the very end, divide by 4. So it's going to take her about 21.75 years. It's a long time to leave your money in an account to double. Okay. There's things called CDs, certificate of deposits, where you can put your money in. You're not allowed to touch it. And you make a better interest rate that way. Yeah. Okay, so you're pretty good. This is stuff we did last year. It shouldn't be too bad. Here's some new stuff that's pretty bad. Here we go. Letter B. All right, we're going to do 2 more things. I'm going to give you 2 more formulas. The funny thing is people mess these up all the time. They mix them up, and I don't know how you can get these mixed up because they're totally different. So I know. This is called future value, and the other one's going to be present value. So let's say that you are working at your job, like me, and I have a pension. I have a pension plan. And my pension gets taken out of my paycheck twice a month, every paycheck. Okay? So that's different than I'm investing $1,000 and walking away. I'm putting money into my account that's making money, and I'm putting more money each time. How do we do that? Here's a formula for it. Here it is. The future value is equal to capital R. I'm going to tell you what that means in just a minute. Now, the book gives you a totally different equation, a formula for this. I like this formula better. 1 plus R over K to the KT, that looks familiar, minus 1 over R over K.
Wow.
Yeah, pretty bad, huh? You could put brackets around this. I think that helps a little bit. It makes it a little bit more complicated, but it puts all that stuff together and then times R. Now, R is, everything else is the same. The little r is your interest rate. K is how many times per year you're doing this. T is the number of years that it's going for. R is going to be whatever your payments are. So, for example, if you decide to take out of your paycheck $200 each time, that's what that is. Okay, it's almost like the principal, but it's not. It's the same amount every time. If that's adjustable, then that makes this a totally different problem, but it's not. It's going to be the same every time. So here we go. Let's go ahead and do one. Number, what are we on, 3? Okay, 4? I don't know. 3, okay. So, Emily. It's a younger name. Emily is going to invest in her future. She's very smart. And she's going to make $500 payments into, it's called an annual annuity. That doesn't matter. Annuity. I'll write it down for you. So if you see it tonight, it won't be weird. Payments to annual annuity. I think it's just, oh well, never mind. And she's going to do this quarterly. Okay, so she's not doing it per paycheck. She's just going to do this 4 times a year at 7.88% interest. That's really good. Pretty much impossible, but pretty good. And this is going to earn her some money, and she's going to leave it in there. And what is the value after 20 years? Okay, what is her future value? See, it's funny because I'll put this on the test as FV, future value. So you should know that this is going to be one of these problems, okay? An annuity problem, a retirement problem, your future value. So let's go ahead and we're going to plug everything in, okay? So the future value is equal to, we know her monthly payments, that's R. She's paying $500, well, not monthly. This is a quarterly problem. $500 per quarter. And so that's going to be times 1 plus, and you just plug everything into this formula I give you. 0.0788 divided by K. What's K? 4. Good. All of that is raised to the, and you can do this right away if you want to, K times T. Do you know what that would be?
4 times 20.
Yeah. So 80 to the 80th power minus 1. All of that is over 0.0788 over 4. We got to punch all this into our calculator. Now, please do me a favor. On your test, because this will be on the calculator section on Friday, at least write it all down, okay? So that if you do mess it up in your calculator, at least I know that you know which formula to use and all that stuff, okay? Here's how I do it. Here, I'll even show you with my calculator. I like to do parentheses. I like to do the numerator of this first. Like leave the 500 alone. So parentheses 1 plus 0.0788 divided by 4. We're going to raise that to the 80th power and arrow down and then subtract 1. I like to hit enter right there. Okay, so that's the numerator of this fraction. Now I'm going to divide by parentheses 0.0788 over 4. Close the parentheses. Hit enter. And finally, I'm going to multiply that whole thing by $500. So at the end of 20 years, she will have a total of $95,483.39. It's pretty amazing, right? Yeah. And then she can retire. Yeah.
Do you guys put parentheses around the
This, if you don't.
The top with the 1 plus.
Oh, yeah. Because it's the whole thing that you're doing to the 80th power.
So
oh.
what? But I mean, like 1 plus in parentheses the 0.0788 divided by 4 parentheses and parentheses.
If you're going to do it all in one thing, you need a whole bunch of parentheses. That's why I don't do it that way.
Okay.
Yeah. So what I do is I'll do the top, enter, divide by the bottom, enter, then times 500. That way I don't have to do all those parentheses. Okay. Now, let's do the other one. Last formula. And this is going to be present value. Okay, this is not about your future. It's not about, how much money you're going to have in your account. This is totally different. Present value is going to calculate a loan. Calculate a loan. So if you go over to the Cerritos Auto Square over here and you want to buy a car, and they say, okay, the car is $20,000, but you have to pay 3% interest, but you're like, oh, I want to put some money down. What are your payments going to be per month? Okay, this is a monthly payment thing. Like, can I afford it? You're going to calculate a loan. This could be a mortgage problem. If I buy a house for $500,000 and it's going to be, 3% interest over the next 30 years, can I afford this house? What will my monthly payments be? This is the formula that does that for you. We call it PV for present value. So the present value is equal to R, which is going to be the monthly payments that we're going to figure out. R is the question mark in this problem, okay? And we're going to multiply this by 1 minus, parentheses, 1 plus R over K to the negative KT over R over K. Aren't you glad that I give that to you? Yes, you are. Yeah. I don't even memorize it. It is. It's a lot similar to the other one. Yeah, it's got a negative KT. The minus 1 is switched. Yeah. Okay, so here we go. Last one. Number 4. Number 4. What happened? I do. I give you the formulas, but I don't tell you which one to use for which problem. Okay, so you need to know that. So if you got a problem like this, and I say, Carlos wants to buy a truck. We can't just have a bunch of old white people in our problems. Okay. Carlo, no. He wants to buy a work truck, truck. And the truck is $18,500. Thank you. And he's going to put $2,000 down. $2,000 down. So then he needs to finance the rest of it. You know what that means, right? So he's got to make payments on the rest of the money that he owes. He's going to have a 4-year loan. So he'll have it paid off in 4 years at an APR of 2.9%. Did you ever hear that on commercials?
Yes. Yeah.
APR, annual interest rate, annual percent rate. Yeah. So Carlos wants to buy a truck. $18,500 is going to put $2,000 down, 4 years, 4-year loan at APR of 2.9%. How much will his monthly payments be? How much will his monthly payments be? Now, you probably don't have bills. Do you have bills yet?
Yes.
You do? And do you pay it once a month? Maybe you have a phone bill. My phone bill is $80 a month. Okay, my mortgage, once a month. It's a lot. It's like, I don't want to tell you. All my bills. The bills are monthly, okay? You're not going to pay a bill like every quarter. Although, actually, water, and anyways. So, but if you're going to buy a truck, you're going to pay a monthly payment each month and for 4 years. Okay, so let's find out how much his monthly payments are going to be. So this is present value. So PV, I know. He is going to put $2,000 down, so he is going to finance a present value of $16,500. That's what PV is. R is the question mark. R is the monthly payments he's going to make here. And then the rest of it I have. I know what it is. It's 1 minus, parentheses, 1 plus R over K, so 0.029 over 12 raised to the negative K times T, so negative 48, 4 times 12, okay, over, I'd probably put parentheses down here just to remind myself to do parentheses, 0.029 over 12. Okay, this is pretty complicated. Please, once again, write this down on your test so that I know that you're doing the right formula, okay? So this one's always, the present value formula is always used for a monthly payment that you have to make. It's your present right now. So what you're going to do is you're going to find out what this number is right here, this big, huge thing, and we're going to take 16,500 and divide it by that because it's just ours being multiplied times that. So here we go. Let's see if we got it. I would do 1 minus, parentheses, 1 plus 0.029 over 12 raised to the negative 48. I would do that first and hit enter. Okay? Then I would divide it by parentheses 0.029 over 12. So 45.269. So then I would take 16,500, the amount that I need to finance. I took the 2,000 off already because he put that down. And I'm going to divide it by that answer that I got. And there it is. So Carlos needs to make payments of $364.49. So each month his payment of his truck is going to be due. He's going to have to pay that. And then at the end of 4 years, that's what it'll be. Now, you could also, if you wanted to, which a lot of people don't like to do, is you can calculate how much you actually paid for your truck. You know what I mean? The truck is $18,500, but you're going to pay more than that because you're financing it. That's why you shouldn't let your credit cards roll over either. You go and you buy, a couch for $500 or something. You put it on your credit card, and then next month, oh, I didn't pay it off, and now you're accruing interest, and that's really bad. On a car, it's fine. On a house, great. It's an investment, sort of. I mean, a car's a really bad investment. It's not an investment. But on credit cards, no, don't do that. And the credit cards are like 18%. Carlos has got a good deal here for 2.9% on his car. That's good. My house, I have a great rate on my house. It's under 3, or is it around 3? It's good. Okay. If he's going to pay $364.49 each month for 4 years, he's going to pay $17,495.52. He already paid $2,000, so he's actually going to pay $19,495 on a truck that was $18,500. That's not that bad. Okay, that's not too bad. You get that?